Okay, we're now going to look at the different forms of acceleration. And the most common thing that we know about acceleration is dv dt, so it's a change in velocity and change in time. Right, so if you have velocity and you derive it, you get acceleration. However, acceleration could also have been the second derivative of displacement, because if you derive displacement once, you get velocity. If you derive it again, you get acceleration. Now, we might need to use different forms. If we have a look at dv dt, we could actually write dv dt as dv on dx times dx on dt. Yeah, this is like we do chain rule, related rates, etc. So the x's would cross out and you'd get dv dt. Now, dv dx doesn't mean anything, so we'll just write that down. But dx dt, the derivative of x in terms of t, is actually velocity. So what we have now is that acceleration can also be written as v times dv dx. Now, imagine v dv. We could actually think about this as v dv over dx, just mucking around with what we actually do here. Now, v dv means the antiderivative of v. So you have d dx, which we have, and the antiderivative of v is a half v squared. So this is another form of acceleration. So we have dv dt, we have the double derivative d2x dt squared, we have v times dv dx, and then we have d half v squared dx. What we use depends on what we've been presented with. So let's start off with an example where we have acceleration is equal to 2 plus x squared, and we know that v equals 3 and x equals 1 when t is 0, and we want to know v in terms of x. So the reality is that we've got acceleration and we want to get back to velocity. How do you do that? You'd normally say to me, anti-differentiate. Now that would be easy. However, if we wrote dv dt is 2 plus x squared, which is what we normally think of as acceleration, you can't do anything with that. You can't anti-differentiate x's in terms of t's, you can't flip it, you can't do anything. So we're going to ignore that. We need to write another form of acceleration. I'm going to write this as d half v squared dx is equal to 2 plus x squared. No? This is just another way of expressing acceleration that we decided on the previous page. So that means that a half v squared is equal to the integral of 2 plus x squared in terms of x. Just bring the dx over like we normally do when we anti-differentiate. So we get a half v squared is the antiderivative of this in terms of x. So you get 2x, you get x cubed on 3, and you get a c value. They gave us some initial conditions. They said v was 3 when x is 1, so let's sub in 3, so you get 9 on 2 equals subbing in 1, you get 2 plus a third plus c. So 9 on 2, which is 4.5, take away 2 is 2.5. 2.5 is 2 and what? 3/6. You take away a third, which is 2/6. Check it through, but I think you'll find that c is 2 1/6. So that means a half v squared is equal to 2x plus x cubed on 3 plus, I'm going to write it as 13 on 6. Okay. We now want an expression for v. First of all, we'll get rid of the 2, so v squared is 4x. 2x cubed on 3, and times in by 2 we'll get this to be 13 over 3, and so v is the square root of all that. Now, reason we chose the positive root is because up here, when x is 1, v had to be positive 3, therefore we only need the positive root. Done. This time we'll look at finding x in terms of v, given that a is 3 minus v, and you've got x equals 0 and v equals 0. Okay, so we're looking for x in terms of x in terms of v, which means we need to anti-differentiate. Okay, we've got v is 0 and x is 0, so let's go with v dv dx, which was one of our forms of acceleration, equals 3 minus v. Right? I do that because I'm talking about x's and v's, so I don't need to have any t's anywhere in there, so that's why I chose that. And that means dv dx is 3 minus v over v. Okay, you should recognize now v on top, v to the side, so it's a type 2 equation, which means we flip it, and we need to practice our calculus. So dx dv is v over 3 minus v, which means x is the antiderivative of v over 3 minus v in terms of v. Now, there's a couple of ways of doing this. We could do linear substitution, okay, or because the top is bigger than the top is equal to the bottom, we could do division. I'm going to do division. So imagine you're doing 3 minus v into v. It'll go negative 1 time, so that'll give you v minus 3 as a multiply through, take away, you get 3. So x is the same as the integral of negative 1 plus 3 over 3 minus v dv. Okay, you can try doing it with linear substitution. Should be capable of doing that at this stage and find that it's the same answer. Well, you'll see how close it is anyway. So now we're going to anti-differentiate x in terms of v, so that'll become negative v. And alright, so we've got negative v minus the antiderivative of 3 over 3 minus v is negative 3 log 3 minus v plus c. What did we know? We knew that x is 0, v is 0, so you get 0, 0 minus 3 log 3. So if you put 0 in, you get c is actually 3 log of 3. So x is negative v minus 3 log 3 minus v plus 3 log 3, which can be simplified to 3 log 3 over 3 minus v. Right, so there's our answer for x in terms of v. Now, if you tried linear substitution here, you should find that you get close to the same answer. You might end up just being slightly different because of a constant.